This video is going to discuss ions. Now, ions are just charged atoms. Now, how can an atom get charged? Well, in a neutral atom, the number of protons and the number of electrons are equivalent. Hopefully that makes sense, because remember, protons, each proton has a +1 charge, and each electron has a -1 charge. So if the atom is neutral, the amount of positive and negative charge have to cancel out. So the protons and electrons have to be the same. And as I stated previously, you can't change the number of protons because then you're changing the entire identity of the element. So the only way to get a charged atom, or an ion, is by either gaining or losing electrons. Now, if you gain electrons, so I've seen a lot of students in the past get confused with this, because they think, oh, gain electron. You gained, so you've got to be about +1 now. But remember, electrons have a negative charge. So you're gaining a negatively charged particle. If you're gaining a negatively charged particle, you're going to become more negative. So, gaining an electron actually makes a negative ion. And this is referred to as an anion. So an anion is just a negative ion. And the species that gain electrons and form anions are nonmetals. So nonmetals will always be gaining electrons. Technically not always, but the vast majority of the time. And always if they are interacting specifically with metals. Which brings me to the other way to form an ion is losing electrons. If you lose electrons, now you're losing a negatively charged particle, so you're becoming more positive. So losing electrons leads to a positive ion. And these are referred to as cations. Cations are formed from metals. So metals will always form cations. Metals will never gain electrons. They will always be losing electrons. So, for instance, let's say we have molecule lithium chloride. So we've got LiCl. Lithium will lose 1 electron, and chlorine can gain 1 electron. And make sure you know that that's the same electron. So, and I'm going to discuss this further in another video, but lithium will be losing 1 electron, and it will be giving that electron to chlorine, so chlorine can gain it. Right? So this lithium +1 ion is a lithium cation, and this chlorine -1 ion, -1 ion is a chlorine anion. Now, I want to talk about relative size of the ions. So let's say we have an atom here. So the nucleus is not changing when you're dealing with ions. It's just the number of electrons in this electron cloud. And electrons are all negatively charged. And particles of the same charge do not have an attraction to one another. Right? Opposites attract. So things of the same charge like to repel each other. So the electrons are all going to try to keep their distance as much as possible. It's like, they were social distancing well before we had to. Now, if you're a positive ion, so you lose an electron, now there are fewer electrons to have to space out from one another. And if there's fewer electrons, they don't need to space out as much. I mean, think about it as if you have 10 people in a room, and let's say right now we're trying to keep our distance, right? And you have 10 people in the same room, and they all have to stay 6 feet apart. If somebody leaves that room, well, now it's not quite as hard to space out. And the more and more people who leave the room, it makes it easier and easier, so you can actually get you don't have to spread out as much. Like the whole crowd of people can fit into a smaller area because they don't need to all spread out as much from each other. Likewise, when an atom loses an electron to form a positive ion, that cation ends up smaller than the parent atom. The parent atom is just the neutral form of the atom. It ends up smaller than the parent atom because there are less electrons repelling each other and trying to space out. And the inverse of that, if you gain electrons, so now let's say we have 10 people trying to space out, and more people walk into the room. Well, now we need a bigger room, right? We need more space to make sure that everyone can keep their distance from everyone else. So in that sense, if you are gaining an electron, anions end up larger than their parent atom. And then one other thing I want to talk about is actually, so the mass symbols that I was talking about in a previous video, there's actually one more aspect to it. So I mentioned these symbols here, chemical symbol, the mass number, the atomic number, but there's one other aspect to these. In the upper right hand corner is the charge, right? And so you don't need to put the charge if it's neutral, but if there is a charge, you need to put it in that upper right hand corner. So let's use chlorine as an example. So we've got chlorine, it's atomic number 17. I'm going to say this is chlorine 35, and it has a -1 charge. So if I gave you this, and I would ask you, how many of each subatomic particles does it have? Well, protons is easy. If you know either the atomic number or the identity of the element, you can know the protons by just looking at that element on the periodic table, or looking at the atomic number if you're given it 17. Neutrons. So remember, neutrons, you do the mass number minus the atomic number. So 35 minus 17 is 18. And then for electrons, so E minus, that's the symbol for electron. Alright, now remember, I said before that in a neutral atom, the number of protons is equivalent to the number of electrons, because the charges have to completely balance each other out. This is no longer neutral now. This has a -1 charge. So that -1 charge, the way you can look at that is, it's like it's saying it has one more of the negatively charged particle. Right? You can't change the number of protons, again, because that would change the identity of the element. And if it has to have one more of the negatively charged particle, that means it needs one more electron than protons. So we would have to have 18 electrons.